Have you ever wondered why certain things in the world behave the way they do? Welcome to the fascinating realm of science, where curiosity fuels discovery and experimentation paves the way to understanding. Science isn't just a subject, it's a way of looking at the world around us, a method of exploring the mysteries of nature. It's through science that we begin to comprehend the seemingly inexplicable, turning the bewildering into the understandable. In this journey today, we'll be exploring 10 crazy science experiments, each one a unique testament to the marvels of scientific exploration. These experiments aren't just fun to watch, they're gateways into understanding the profound laws that govern our world. From physics to chemistry, from the ordinary to the extraordinary, each experiment unravels a piece of the puzzle that is our universe. So buckle up, fellow explorers, get ready to dive into the world of science as we unravel the mysteries of nature. Ever thought an egg could float? Well, science says it can. Welcome to the floating egg experiment, a fun demonstration of density and buoyancy. All you need is an egg, some salt, water, and a couple of glasses. Here's how it works. First, fill one glass with fresh water and gently drop the egg in. Notice how it sinks. That's because the egg is denser than the water. Now, in the second glass, dissolve a good amount of salt into the water. This increases the water's density. When you place the egg in this salty solution, it floats. Why does this happen? It's all about density. The salt water is denser than the egg, so it pushes the egg up. It's like the egg is being held up by a cushion of water. In fresh water, the egg is denser, so it sinks. So the next time you see an egg, remember it has the potential to defy gravity. Scene script. Can a balloon inflate itself? Let's find out. Our recipe for self-inflation calls for a balloon, vinegar, baking soda, and a bottle. First, we take the balloon and fill it up with some baking soda. Next, we pour vinegar into the bottle. Now we attach the balloon to the bottleneck, but we're careful not to let the baking soda drop in just yet. Ready? Once we let the baking soda fall into the vinegar, a chemical reaction occurs. The vinegar, or acetic acid, reacts with the baking soda, which is a base, also known as sodium bicarbonate. The reaction produces carbon dioxide gas. This gas has nowhere to go but up, filling up our balloon. What you're witnessing is a prime example of gas expansion. When a gas is produced, it needs space, and so it expands, inflating our balloon in the process. Just as the balloon inflated, so did our knowledge. Ever seen milk behave like a magic canvas? Prepare to be amazed. For this experiment, we'll need some household items: a dish of milk, different colors of food coloring, and a drop of dish soap. Start by pouring milk into a dish and then scatter drops of food coloring around. The real magic begins once you add the dish soap. The soap sets off a riot of colors, swirling and mixing in the milk. It's not just a pretty spectacle, but a science lesson on surface tension and chemical reactions. When the soap is added, it breaks down the surface tension of the milk, causing the food coloring to swirl and dance. The soap molecules are trying to join with the fat molecules in the milk, and in the process, they create this colorful display. So, what we're seeing is the visible effect of surface tension at work and the interaction of different molecules. Who knew milk could be so colorful and exciting? Who said water can't walk? It's time to challenge that notion. Now, for our fifth experiment, let's delve into the fascinating world of capillary action with the walking water experiment. This one's a real crowd pleaser. For this, you'll need some basic household items: water, food coloring, paper towels, and cups. The experiment begins by filling alternate cups with colored water and leaving the others empty. Then, we place paper towel bridges between each cup. Watch as the magic unfolds. The water seems to defy gravity and walk up the paper towels and down into the empty cups, creating a stunning mix of colors. But what's the secret? It's all down to capillary action. This is the ability of a liquid to flow in narrow spaces without external assistance, or even against gravity. It's the same process that helps plants draw water from their roots. Next time you see water, remember, it has the ability to walk. Scene script. Can raisins dance? Science says, yes, they can. Let's dive into the dancing raisins experiment. This fascinating experiment needs nothing more than your everyday raisins and some clear soda. Here's what you do. Drop a handful of raisins into a glass of soda and watch. You'll see the raisins start to dance around, bobbing up and down like they're grooving to a beat. But what makes this happen? The answer lies in the scientific principles of buoyancy and the formation of gas bubbles. The carbon dioxide in soda forms gas bubbles around the rough surface of the raisins. These bubbles lift the raisins to the surface. Once they reach the top, the bubbles pop, and the raisins sink back down. And thus, the dance begins anew. This experiment isn't just fun to watch, it's a great way to understand the science behind everyday phenomena. Just as the raisins danced, so did our curiosity. So, what's the takeaway from all these experiments? Well, Let's dive into the heart of what we've uncovered today. Each of these experiments, though seemingly simple, provides a fascinating glimpse into the intricate and awe-inspiring world of science. In the floating egg experiment, we witnessed the power of density and buoyancy. This is the same principle that allows enormous ships to float on water and hot air balloons to rise in the sky. It's not magic, it's science, and it's happening all around us. The inflating balloon experiment showed us how chemical reactions can result in physical changes. The vinegar and baking soda reaction created carbon dioxide, inflating the balloon. This is a great example of how chemistry is involved in our everyday lives, even in something as simple as baking a cake. Then we moved on to the magic milk experiment. By adding a drop of soap to milk with food coloring, we saw a burst of colors swirling around. This happens because soap reduces the surface tension of milk, causing the colors to dance around. It's a playful reminder of how physics and chemistry can create beautiful effects. In the walking water experiment, we saw how water can climb up paper towels and mix colors together. This is due to a process called capillary action, which is the same process that allows trees to get water from their roots to their leaves. The dancing raisins experiment was a fun demonstration of buoyancy and gas bubbles. We watched as raisins danced up and down in a glass of soda, showing us that science can be as entertaining as it is enlightening. All these experiments reinforce the idea that science is not just confined to a laboratory. It's a part of our everyday lives, shaping the world we live in and how we interact with it. It's in the air we breathe, the food we eat, and even in the fun we have. Remember, science is not just in labs or textbooks, it's in everything we do and see. Keep exploring, keep experimenting.